Last video of the night, and I'm going home now that traffic's died down finally. Alright, so we got AP Calculus AB sample test number 4, multiple choice 38 through 45. Calculator. Get your calculator because you're going to need it. Let's jump into it. The slope of the function f of x. Whoa, this is interesting. Whoa, because they say this differently than what we're used to. It says the slope of the function. What's the slope of the function? Well, that's the derivative. And the derivative of 0 to x arc sine of t when x equals 0.4, x equals 0.4. That means that we're trying to find f prime of 0.4, which means this is like fundamental theorem of calculus where those reduce, and we're going to wind up having this just plug in because this is just x and this is a constant, so we don't have to worry about chain rule happening. So f of 0.4 is really just arc sine of 0.4. Wow, that's so easy if you know what it's asking. So let's type that in. That means we're going to do second sine arc sine of 0.4. 0.4115. I guess that would be this one here. C. That was a super fast question. Number 39. Alright, let's see if we can see this a little bit better. Scroll up. Let g of x be the function defined by 3 to x of this times this, which the following statements about g must be true. G is increasing on 3 to 5. Well, how would I figure that out? I don't really care about the area so much, because if I'm asking about increasing, that's saying is g prime of x positive, and if g prime of x is positive, g prime of x is equal to just 5 plus 4x minus x squared times 2 to the negative x. That's what g prime of x equals. So let's see if that is in fact positive by graphing it. So 5, this is again fundamental theorem of calculus coming out here. We got 5 plus 4x, so let's type that in. Clear this one out. We have 5 plus 4x minus x squared. Ooh, we gotta group all that together. I gotta insert a parentheses in here. Ooh, too far. So I'm going to do second delete, which gives me the insert. I'm going to insert a parentheses in there. Gotta scroll all the way over. And then put a parentheses here. Okay, it's that times 2 to the negative x. Negative x. Alright, let's graph this. Oh, we're looking between 3 and 5. That would be helpful to see that area. So we want from 3 to 5. Do we want any others? From 3 to 7, it looks like. From 3 to 7, and yeah. So let's go from 2 to 8, just to give ourselves a margin on each side. And for the y minimum maximum, let's do negative 10 to 10, pretty standard ones. See what we can get from that. Now let's go to our graph. Okay, so I have a graph here. It looks like it doesn't actually go that high or low, maybe up to 5 and down to not even lower than 0. So let's see what we got. Y minimum, I'm going to go to negative 2. And for y maximum, let's go to 5. Okay, so there's my picture. So the question is, how does this picture relate to the things that we're looking for? Okay, so here is 3, or this is from 2 to 8, pardon me. So here's 2, 3, 4, 5, 6, 7, 8. So for this entire time, g prime is positive. Therefore, it is increasing on 3 to 5, and it's also increasing on 5 to 7. Not very much, but it is increasing. And it says g of 7 is less than 0. G of 7. Well, for me to figure out g of 7, that's asking me about the area, because g of 7 is the area from 3 to 7 under this function, and the area does not look negative, so that would not be true. So it's 1 and 2, but that's not even an option. So what's going on here? If I'm looking at this, the area from 3 to x of this integral, from 3 to x, so it means start at 3 and then go to 7, that should still be positive. So 3 should be out. Is g increasing on 5 to 7? Well, let's see what's happening right at 7 if I were to plug that in. So I'm going to pull up my graphing calculator again. I'm going to trace and see what my value is at 7. At 7, I'm at 0.1484. Well, maybe g of 7 is less than 0 for some reason that I'm not seeing. The other thing I need to check is make sure that I typed this all in correctly. We have 4t minus t squared. So if I go back to my y equals this, we got 5 plus 4t. So 5 plus 4x. Oh, that says minus x times 2. That's not really x squared. I think that might make a difference. So this is x squared. Now let's go to our graph. Ooh, okay, now we got some different action going on. So we got to fix that. Notice that I knew to fix it because none of the answers were making sense. So I'm going to clear this off and start from scratch here. Not completely scratch because we kind of know what we're doing now. So we'll pull this over. Okay, so now when we're looking at this graph, remember it started at 2, then 3, 4, 5, 6, 7, and we go to 8. And it might even be better if we could see closer, but I can tell that between 5 and 7 that it's negative, and from 3 to 5 it's positive, just by looking at it. So that means 1 is true, but 2 is not, because it's g prime of x is negative. So it's actually decreasing. It should have been decreasing instead of increasing. And it says g of 7 is less than 0. Well, I wouldn't say that because g of 7 is the area from 3 to 7. And that means that this area here, this positive, would be less than this area here, which is negative. And just by looking at it, that doesn't look true at all. It looks like the positive area is greater than the negative area. So that means the overall change would still be positive. So I'm going to say that 3 is false as well. That would mean that 1 only is true. Number 40. Actually, let me go back. Everybody's always saying, Mr. Butler, you got to wait so we can pause it. So pause it. Go ahead. Now I move. The region enclosed by the line x plus y equals 1 and the coordinate axis is rotating about the line y equals negative 1. What is the volume of the solid generated? Alright, well let's see what we got. That means that we have x plus y equals 1. That's the same as y equals negative x plus 1. So we have a function that's pretty linear here. Let's draw a picture. So we got x and y axis. Y equals negative x plus 1 is just a straight line. Looks kind of like this. And says that we're going to rotate it around the line y equals negative 1. So that would be down here. We'll draw that in blue, I guess. Well, it didn't come out blue, but that's okay. Just draw over it. So we're going to rotate around that line. So we got a couple of questions to ask ourselves. First, when we're doing a volume rotation, it's good to know if we're attached to our axis, and we're not. We have all this empty space in here. There's not attached, so there's all this emptiness. And that little emptiness is going to represent our inside radius. And the area, or the volume of this, is equal to pi times little r squared. And then what we're going to do then is we're going to take the whole radius, which starts from the top edge all the way down to here, and that's our big R, and we're going to have the volume of the whole piece minus this inside. So our volume then of the whole piece is going to be pi r squared of that part. And then we're going to subtract the red. So the overall, the volume overall, let's do this in black. The volume net, you could say, the positive minus the negative, is going to be the integral. We got a pi here, and we're going to have big R squared minus little r squared from 0 to 1. How do I know that's what's happening here? Because it's this area enclosed, and it goes from 0 to 1 here, just because I have some knowledge about the graph. If x plus y equals 1, and y equals negative x plus 1, that's going to have an x-intercept here as well as this y-intercept at 1. So big R is going to be this line, negative x plus 1, minus negative 1. So it's going to be negative x plus 2. That's our big R. So it's going to be that squared minus, and then right here we have the integral of just 1 squared, which is just 1. So we're going to have the integral from 0 to 1 of this dx. We're going to multiply it by pi. Now I could do that by hand. I could, but I have a calculator. And it's going to be pretty easy to tell which one of what decimal would equal one of those. So I'm just going to integrate this, but I'm going to leave the pi out of it because I don't need to do that. Let's go ahead and get back to here. So we're going to clear this. We're going to go to our y equals. We're going to clear that graph. We're going to do a new one. This one is going to be the integral of negative x plus 2. And we're going to square that. And we're going to subtract 1 from it. So now we go to our graph. We're going to calculate the integral of this area from 0 to 1. Is that right? I think that is. Let me make sure that I type this in there. Negative x plus 2, then we square it, then we subtract 1. Okay. So we're going to integrate. Second integrate. Where's second integrate? So we do second calc. Then 7. Lower limit is 0. Upper limit is 1. Oh, wait, what's going on here? Second calc. 7. Lower limit is 0. Upper limit is 1. Whoa, how did that happen twice? Second calc. 7. Lower limit, 0. Quit. Why won't it do that? Oh, I know why. Because we're not in the right window. Have you guys ever had this happen to you? You have to actually be in the window. So we need to go from 0 to 1 in our window. Oh, that makes so much more sense because look, this area is going to be positive. Oh, I'm so pleased. Relief. Second, calculate the integral. Now we're working from 0 to 1. You guys have probably done that same thing a ton of times. So the integral is going to be 1 1/3 times pi. So pi times 1 1/3, which is really 4 pi over 3, or e. Hit the pause button if you want to wait. I'm moving on. The function y equals sine of x plus cosine of x is a solution for which differential equation? What that's really saying is that if we were to take the derivative of this, how would it match up with these ones here? So let's see what happens. If I were to take dy dx, in other words, that means I would have cosine x minus sine x. Well, I need to see which one of these are equal to this. Well, if I add this, if I do sine x plus cosine x, and then I were to move that over here, so 2 sine x minus sine x minus cosine x, would that be equal to this? 2 sine x minus sine x, that's sine x minus cosine x. So 1, nope. Y plus dy dx equals 2 cosine x. That would be sine x plus cosine x. Then we move it over to the other side, so it's going to be 2 cosine x. If we move these over, it's going to be minus sine x minus cosine x. Does that work? Maybe. Let's see. Cosine x minus cosine x is going to be cosine x. And then negative sine x. Hey, that does work. So 2 works. Let's look at 3. dy dx minus, now we got y. So this is going to be sine x plus cosine x equals negative 2 sine x. Now if I move those to the other side, that means I'm going to have negative 2 sine x plus sine x plus cosine x. Well, negative 2 sine x and sine x, those would combine to make negative sine x. And then cosine x right here would be plus cosine x. Negative sine x plus cosine x. That works too. So 2, oh, here we go. Whoops. 2 and 3. Check. Move on. The region R is enclosed by the coordinate axes in the graph y equals k times x minus 2 quantity squared as shown above. When this region revolves around the y-axis, the solid form has volume of 8 pi cubic units. What's the value of k? Oh, did I not get the graph in here? Oh, there it is. Okay, so this is revolved around the y-axis. Notice that they underlined that because that's important. So that means I'm going to have to find this function in terms of y. That's kind of weird because it's saying that it has a volume of 8 pi cubic units. And if you look at this, when I revolve it around, you know, I'm going from here to here. I'm going to revolve this one around. And then I'm going to revolve this one around. It's almost like I have to do 2 separate problems. I had to figure out what k would equal. Well, let's see if we can figure this out. It's going to be a little bit tricky. That's why they put the problem at the end of the multiple choice. It's the one that nobody actually got to, so it's not that big a deal. First I need to figure out this in terms of y. My function of y, if I square both sides, I get, it's going to be y squared equals kx minus 2k. So y squared minus 2k divided by k is equal to x. Okay, so that's what that function equals in those terms. So now there's that function. Now because we have this function kind of in 2 different places, this is where it gets a little bit weird. Because we're revolving it around, where are we revolving around? The y-axis. We're going to have to figure out this, just this area. And we're going to have to do this other area. Let's color it red. We're going to have to figure out the red area completely separate. And that kind of sucks. But it'll be okay. We'll figure it out here. So let's start with just this area. Oh, I totally did the wrong thing here. That should have been square root of y. I'm sure you guys are shouting at the screen. Say, Mr. Butler, you don't know how to do your math. So if I square root both sides, then I get rid of that squared. So it's going to be a square root of k. So that's square root of k. And then that's square root of k here and here and here. So let's redo that so we can get this function just a little bit different. So that means that we're going to have, if I square root both sides, I have square root of y equals, actually let's do this, square root of y over k, I divide both sides by k, equals x minus 2. So then we have the square root of y over k equals, or plus 2 equals x. So that's my function of y. That makes a little bit more sense as far as the shape and how it's going to work out with the pieces that we need. Okay, so this is actually going to have a plus or minus here. And I know that kind of sounds weird, but this piece down here, this is going to be minus square root of y over k. plus 2. And this piece over here, this is going to be positive square root of y over k plus 2. So we'll do the blue area. So I'm going to try something here. I have a little hunch, and I think that it might be kind of helping me a little bit to figure out where k is. So first, I want to try and integrate this area here, just the blue. So the area of the blue, or the volume of the blue, is going to be pi times this little r squared. We'll call it like r1. And this right here is r1. And r1 is going to be the negative square root of y over k plus 2. And it's going to be this squared from 0 to wherever this is going to be here. Now, I got to figure out what that thing is. The root axis y equals k times x minus 2 squared. If x is 0, then that becomes 4k. So it's from 0 to 4k. Now, honestly, as I'm looking at this, I'm going to try and graph it. This is a tough question. I think they would actually be wanting us to use shell method for this, which you guys don't even know, but that's okay. Shell method would be so much easier than disk method for this. And I think that's actually what they're going for. You know what, with that in mind, I'm going to scratch this one. We'll go ahead and skip this problem because that's actually a BC type topic. We don't use shells in here anymore. Shells is, we're used to disks, which are pi big R squared, but shell method would be a lot easier in this case, which would be 2 pi r. And that's times, times 2 pi r times the height times the function times the height. Okay, let's skip that though. Let's go to 43. Sorry for wasting your time there, guys. For what values of x, does the curve blah 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 have a horizontal tangent line? Remember, a horizontal tangent line is when the derivative, or in other words, dy dx, equals 0. Okay, well let's take a look at that. That means we're going to have this piece, but we can actually take the derivative of this implicitly. We're going to wind up having 2y times dy dx. Then we got minus 3x squared and minus 30x equals 0. So I need to figure out what dy dx in terms of this equals. And that means that we're going to have dy dx equal times 2y equals, then on the other side we'll have 3x squared minus 30x. So now if we divide both sides by 2y, then we get this. So it's 3x squared minus 30x over 2y. Well, let's see what's going to happen with this. If I try to factor this top, that would give me 3 times x squared minus 10. Is that right? X squared minus 10. Oh no, if I pull out a 3x, there we go. That's what we're looking at. That makes a lot more sense with the answers that we have. 3x gives me x minus 10 on the inside here, and then 2y. Now the key at looking at what's going to happen is knowing what you can and cannot do. If we have a horizontal tangent line, that means the top equals 0, but the bottom is not 0. That's huge in understanding this. So the top is 0, but the bottom is not 0. Because if we have 0 over 0, that's kind of undetermined. It's an indeterminate form, and we can't know what slope that has because it's more of a hole. So here we got 3x times x minus 10. If I were to plug in x equals 0, you would think the top equals 0. But the problem is that if x equals 0, then so does this, then so does this. That means y equals 0 too. Because if I plug into the original equation, that tells me what y would equal. So that wouldn't work. X equals 0 does not work. So I'm going to actually cross out all those. x equals 0, x equals 0, x equals 0. But if I were to plug in 10, that does work if x equals 10. Because if I plug in 10 to the original equation, that's going to be, what, negative 1,000? This is minus 1,500. So y squared is not going to be 0. It's going to have some other value. So if x equals 10, y does not equal 0. Therefore, it is a horizontal tangent, because that allows us to have 0 over a not 0 number. So it would be at C, x equals 10 only. If f is a continuous odd function, that's interesting, and the limit as x approaches, that odd is important here for a second, I can feel it. The limit as x approaches negative infinity, notice that, negative infinity, that seems important too, is equal to negative 3. Which of the following statements must be true? So here's something about odd functions. Whatever's happening on the left, if it's going to negative 3 on the left, that means the opposite's happening on the right. It's going to positive 3 as a horizontal tangent. Then that means that, yes, 1 is true because it's odd. That's what tells me that the right side is kind of inverse numerical values of the left side. There are no vertical asymptotes. I don't know. Who the heck knows what happens here in the middle? Sure, we could have vertical asymptote. Let's just make one. Boom! Vertical asymptote. The lines y equals 3 and y equals negative 3 are horizontal asymptotes. You betcha. Because a horizontal asymptote has to do with the limit as x goes to infinity, or the limit as x goes to negative infinity. And we showed that one of these is 3 and one of these is negative 3. So yes, those are both horizontal asymptotes. 1 and 3 only. Because it says which of the following statements must be true. And it could be true, but we don't know. In this case, we're going to say no. 45. Which of the functions given below has an average or mean value of 0 on the interval negative a to a greater than 0? Oh, an average value of 0. So the average value equals 0. The average value then is the integral of 1 over b minus a from a to b. So if it's got an average value of 0, here's what's interesting. What is that really saying? That's saying that whatever positive area you had, if you're going from A to B, whatever positive area you had on one side, you have the equal negative area on the other side. So that means over this interval, that wherever it's split down the middle, that the negative and the positive are going to be equal. Now notice that the split down the middle is from negative a to a, so that's really talking about a graph that's very symmetrical. And in fact, it's symmetrical the same way as it was in those previous questions that we just looked at. Like this one, where it's symmetrical. On the right side, it's going to the horizontal asymptote of 3, and on the left side, it's horizontal asymptote of negative 3. Those are called odd functions. And odd functions have that symmetry. So this is some type of odd function. So all you got to ask is which of these functions are odd? Sine of x, check. Cosine of x, no. Square root of x, no. Absolute value of x, check. X squared plus x fourth. I don't know. I think so. But let's double check. Why? Because I have a graphing calculator. And I can do that because I want to. X squared plus x to the fourth. Then I graph it. Oh wait, I got to check from like negative to positive here for a second. Let's see. Our window. We're going from negative 3 to 3. How about that? No, it doesn't have this negative-positive relationship. It's got a positive-positive relationship. It's even. So only A and D. But now, wait a second. Which of the functions given below has an... Oh, wait a second. D does not. It's got positive-positive relationship too. So it's just A, sine of x. Sine of x is the only one that has that equivalent negative and positive areas. And that's it. Next are the FRQs, but I'm not doing those tonight. Good night, y'all.